the radius of the semicircle is this. This is where you realize, if you're talking about the semicircle over here, make sure you're looking at this part of the diagram, okay? And you know this is the semicircle over here, you're just talking about this particular distance, which hopefully is very obvious to you that it's going to be part of this triangle over here. Remember the rule of doing these types of questions? The information they tell you not to look at or try to find is usually the information that you have to label in anyway, if it is very obvious. As in, it's pretty obvious over here there's a triangle, it's pretty obvious how you can work out these lengths, so it just makes sense to work these out. So without further ado, you'd realize that this radius over here is going to be this that you need to prove. Find the actual radius. Realize it's going to be this length, which is part of this triangle over here, which is what this is representing. It's a right angle triangle here. Right angle triangle, if this is 10, it's the hypotenuse. This is the distance we want to find, opposite. This is going to be 0.2 radians. Remember, calculator, default mode is going to be radians. Shift 4 radians modes. Very simple to do over here. It's just sine SOHCAHTOA. Sine is equal to opposite of a hypotenuse. Sine of this angle over here, which is 0.6, is equal to x over 10. Rearrange for that, it's going to be x equals to 10 times this, which is where we get 5.646. We proved it. The mistake with these types of questions, realize that if you're looking for the perimeter of the metal plates, don't think too much about the numbers, think about what even makes up the perimeter in the first place. Do we realize it's going to be this distance plus whatever this distance is? So far so good? So the first step is to outline what we're even trying to find over here. And then we can find them individually. We isolate the question. We just look for, say, sector A or B, which is going to be A or B. Isn't that just going to be this outside over here? So this is where you realize it's the same thing as finding the arc length. Remember, arc length is going to be typically, when you're looking for arc length, it's just going to be, you have a circle and you have an angle over here and you can find this distance by doing this angle over here times by the radius. It's not really any different over here. It's but what you realize here is the same thing as doing radius theta r. Remember, arc length is equal to theta r. It's the same thing as doing this angle over here, this big one, times by this radius. Do you see how that gives you this particular distance from A to 0 to B? Yes or no? And this overall angle, you'd realize, well, it's going to be 360 minus whatever this angle is, isn't it? Which is the same thing as doing 2 pi minus this angle, because pi represents 180 degrees. So 2 pi is going to be 360 degrees. So 2 pi minus this is going to be this angle over here. 2 pi minus this. 2 pi minus this times by the radius is going to be this distance over here. So that's how we found sector A or B. Notice how we didn't really expand this, like we just left it as is, and you'll see why this is helpful later, because this fully encapsulates the length over here. The sector. Just leave it as that and you'll see why it helps later. Arc BD. Arc BD is going to be this. Isn't this arc BD the same thing as, well, isn't that just part of a semicircle? This is the mistake you must make sure you don't make over here. Okay? Do not confuse this thing from 1.2 times 10. That is not the case. 1.2 times 10, theta r over here is going to give you this one, isn't it? It's part of the other bigger circle. This is a separate circle, isn't it? We're trying to find the separate circle length over here. It's half the circumference, which is why over here, instead of doing 1.2 times 10, which would be finding this length, we're supposed to find this length over here, which is, it's just going to be 2 pi r divided by 2. Well, we already know what the radius is going to be. Radius is 5.646, so 2 times pi times 5.646 divided by 2, which gives us this. And then final answer is just going to be, well, we just take these two individual numbers and add them together, don't we? This plus this, which is what we did over here. And as we get 68.6. Part 3, finding the area of the metal plate. The area of the metal plate is just going to be what? It's going to be this area, isn't it? This is where you realize, remember, same principle. We don't focus too much on the numbers over here because it's very easy to get overwhelmed by the numbers. Instead, we just realize common sense, even if we don't know how to do the math, we'd still know what makes up the area. We know it's going to be this Pac-Man shape, this big sector, plus this triangle, plus this half circle, which is, there's nothing really stopping us from finding what? We could find this big sector right now, couldn't we? Let's go ahead and find this big sector. Well, this big sector is just going to be a half times 1.2 times 10 squared is going to give us this sector, right? Is that what we want to find? Or are we trying to find this bigger sector, yes or no? So from my point of view, do not make these logic mistakes. Make sure you understand that you're looking for the bigger area over here, which is going to be 2 pi minus 1.2. A half times this angle times 10 squared. Remember the formula sheet? A half theta r squared for sector area. You following this? Yeah? So we outline first what even makes up the area. Once we know what makes up the area, let's individually evaluate this. See this rule? Like, look how clean this is. Look how logical it is. Look how unmistakably clear all of this is. Sector ABD, sector ABD, this bigger sector over here. Find this angle, 2 pi minus 1.2. 2 pi minus 1.2, a half times theta times r squared. We've got this now. We represent it using this. BOD. BOD is going to be this triangle, area BOD, which is going to be, remember the triangle formula? The universal one, a half AB sine C. Remember that one? It just means you find one of the angles and then do a half times the two sides that make up the angle times sine of one of the angles over there. So a half times 10 squared times sine of this is an example of using the universal triangle area formula. Very sure you're going to be in radians mode for the calculator, no problem. And then last part over here is just going to be half a circle area, pi r squared over 2. Pi r squared over 2. And then a is just going to be these individual numbers added together. Just copy them directly and then type it exactly like this in the calculator and you're guaranteed to get the correct answer, which is 351 centimeters squared.